Okay, so some review of trigonometry now. Question 8a. Show that the sine of 3 theta equals 3 sine theta minus 4 sine cube theta. And they're giving you some clues that 3 theta can be expressed as 2 theta plus theta. So the sine of 3 theta can be expressed as the sine of 2 theta plus theta. And I'm now going to use my laws for compound angles, addition properties. Comes under many different names, but I'm going to use it on this side. So this is equal to the sine of 2 theta cos theta plus cos 2 theta sine theta. And noticing that I only want sines in my eventual identity, then I'm going to have to get rid of all the cos things here. So in order to get rid of this cos thing, I'm going to express sine 2 theta as 2 sine theta cos theta multiplied by another cos theta, that one. And then instead of my cos 2 theta, I'm going to be writing that as 1 minus 2 sine squared theta multiplied by the sine theta, which is here. And then I'm going to simplify that. So I've got 2 sine theta cos squared theta, and then multiplying by sine theta plus sine theta minus 2 sine cubed theta. Okay, so I want it in terms of only sines, so I'm going to have to express cos squared as 1 minus sine squared. And then expand 2 sine theta here. And then simplify. So I've got 2 sine theta plus another one, 3 sine theta, minus 2 sine cubed theta, minus another 2 sine cubed theta, so minus 4 sine cubed theta. Dun dun dun! Show. So I'm now looking at question 8a part 2, and I've got an equation here that says I've got to solve 8 sine cubed theta minus 6 sine theta plus 1 equals 0. Given my answer in terms of pi, and I've got to have theta between 0 and pi when I finish. Now I know that in the previous set of the question I've got 3 sine theta minus 4 sine cubed theta equals sine 3 theta. So I'm going to apply that now, because I'm noticing a link straight away. If I multiply this by minus 2, I basically get this. So I'm going to multiply the whole of this by minus 2. So I've got minus 6 sine theta plus 8 sine cubed theta is minus 2 sine 3 theta. So what do I now know? I know that instead of this, I've got minus 2 sine 3 theta. So I've got minus 2 sine 3 theta plus 1 equals 0. And rearranging that, I can have sine 3 theta is equal to a half. I want to be in radians, so inverse sine of a half gives me pi over 6. And if I now look at my sine function, got a period of 2 pi, I've got pi there, so inverse sine of a half, got pi over 6, that's that solution there. I'm also going to have some other ones. I'm going to have that one, I'm going to have that one. Let's see if I've got a bit further. Going to have that one. Let's look at them. So I've got here pi over 6. Here I've got 5/6 pi. Here I've got 2 pi plus pi over 6. So I've got 13 pi over 6. And here I've got 3 pi minus pi over 6. So I've got 17 pi over 6. And that's obviously 3 theta. So to get theta, I'm going to divide everything by 3. Pi over 18. 5 pi over 18. 13 pi over 18. 17 pi over 18. Okay, now on to 8b. And 8b says using sine theta minus alpha is that expansion. Show that sine 15 is a quarter brackets root 6 minus root 2. So I'm going to use sine 15 expressed as sine 45 take 30, because 45 take 30 have got exact angle measurements and root 6 root 2 are exact. So by the expansion of sine a minus b, this is the same as the sine of 45 cos 30 minus the cos 45 sine 30. And then I'm going to sub in my values, so my numeric values for that. So root 2 over 2 is the sine of 45. Root 3 over 2 is the cos of 30. Cos of 45 is root 2 over 2 multiplied by a half. That's the sine of 30. Simplify that, I've got root 6 over root 4 minus root 2 over 4, and take out the quarter. Root 6 minus root 2. Dun, dun, dun.